So, good evening, my dear friends. Hello, hello. Oh my god. Oh my god. Okay, okay, fine. So, welcome back to our YouTube channel. So, today's video, we are going to see about how to find the semicircular rings center of mass. Okay, this center of mass is a very important chapter. So, it will help you in many other chapters also. And basically, in center of mass, I see many students memorizing formulas, which is not good for you. Due to the vast syllabus of physics, you will forget it over time. Okay, now you won't realize, but when you are forgetting, you should not feel that is of no use. So just start now even. So if you don't know how to, sorry, uh, if you don't know what to be done, if you should not by heart the formulas, I'll tell you, you need to go with the integration. See, integration is a part of calculus, and calculus is going to give you a very good, strong basics in physics. And through calculus, if you are learning physics, you will get stronger concepts. You get stronger in getting ideas during examinations, and you will feel comfortable where you will get variable masses, variable accelerations, variable distances covered in kinematics. So basically, you should be good at differentiation and integration. That's what I'm coming to tell. So with the help of differentiation and integration, even you can derive these formulas for the semicircular ring, etc. So in today's class, we are going to see how to derive it. Don't worry. Now let me take that this is semicircular ring, and this is going to be your x-axis, and this is going to be your y-axis. And now can I tell that this is going to be the origin? Yeah, this is the origin 0, 0. And now I can tell that this is the radius r, 0. And now you tell me if I go for an angle theta, okay? Okay, let me draw it neatly for you. I will come this side for better clarity. Let me tell that we are going for an angle theta. Okay. So I'm taking one more small segment where over here. This is big for you, but I am taking it as small. Okay. So assume that this is a very very small segment. So angle of this small segment is going to be d theta. D theta even represents how small that is. Okay. I hope you know the basics of differentiation and integration. Without that, you won't be able to understand whatever I am telling in this lecture. So here can I tell this is a very small mass, so it's going to be dm mass and length is going to be dl. Yes. And now through since this is given that it's a uniformly distributed mass. Okay. We get that lambda, which is the linear mass density, is going to be constant. If linear mass density is going to be constant, each and every point in this ring, no, it's going to have the same linear mass density. Sorry, not linear mass, linear density. Okay. So even for this dm mass, it's going to have the same linear density. So I can write this as dm by dl. It's going to be lambda. Are you comfortable with this? This dm by dl is going to be lambda. And since I have told you that it's a very very small sector, I can take this point coordinates as r cos theta, comma r sin theta. You may ask, what about this region? I have already told you it's a very very small region, so that you can take this r cos theta, comma r sin theta coordinates here or here or here or here. No problem. It's a very very small place. Okay. Just for your understanding, I have written this big. It's going to be very very small. Let me show you like this. It's going to be very very small. This much small thickness. Okay. Okay. Now let's get back. Fine. Now you would have studied this obviously. There is one circle. It's the center. Let's say This is radius r, this is radius r, and this angle is theta. And how do you find this arc length? L. You have studied this formula, L is equal to r theta. So same formula I'm going to apply here. So I'm going to write dl is equal to r, angle is d theta. So r into d theta. This is very important. If you understood this now, half of the thing is over. Only two major concepts. One is that you need to convert dl as r into d theta. See here, this is radius. This is a radius. It's going to be a sector. Okay. Yeah, very small sector. That's why I'm using dl and d theta. Okay. So from this you can write dl is equal to r d theta. After writing dl is equal to r d theta, you can directly write integral of y com is equal to integral of y dm by integral of dm. You may get a doubt now. So why sir? Why did you use x center of mass? Why did you find the center of mass along x axis? You tell me. Since I assumed that the ring is going to have the center of 0, 0, definitely the center of mass of this ring is going to lie somewhere on the y-axis only, not on the x-axis. I hope you can be clear with this image. Sir, is it compulsory that the center should be 0, 0? No. But for you to understand how much distance is it from the base, that's why I am using 0, 0. During the examinations, you just shift no. They have given some 1, 1, then you need to shift your center of mass by 1 unit towards the right, not 1, 1. Suppose they gave the center of 1, 0, and you know the y coordinate of center of mass, then obviously just shift this center of mass 1 unit away in the x axis. Yeah, that's it. Okay. So for now understanding purpose, I have written like this, no problem. This only majorly they'll ask, if at all they ask like that, now you just shift the center of mass, that's it. Now can I write dm is equal to from this equation, let's say 1, from 1, can I write that dm is equal to lambda into dl, and from this equation 2, from 2, can I write dm is equal to lambda r d theta? Yes, I can write. And now you tell me, what is center of mass along y direction? Y center of mass is going to be integral of y dm. What is y? Coordinates of that point, whichever point we are assuming. This is going to be r sin theta. So r sin theta into dm. What is dm? See here, dm I have written on that dm. We are going to write it like this: lambda r d theta divided by dm. What is dm? Lambda r d theta. Now tell me, what are all the constants over here? Lambda is constant, get cancelled. R is constant, constant, get cancelled. So what is going to be your resulting equation, resulting expression? Your y com is going to be equal to integral of r integral of sin theta d theta divided by integral of d theta. Now tell the limits. Limits starts from 0. From 0 to pi. Angle I am telling, not coordinate. From 0 angle, this is 0 angle, right? With x-axis, what angle is it making? 0 to pi. Total angle is pi, 180 degrees. Okay, 0 to pi is going to be our limits, 0 to pi. So now you integrate, you get the answer r into minus cos theta, limits from 0 to pi. Integral of d theta is going to give theta, limits going to be 0 to pi. Now you substitute the limits, work done. Okay, first substitute pi, we'll get an answer. Keep 1 minus sign, then substitute 0, we'll get an answer. Minus them both, subtract them both, you're gonna get 2r, and first substitute pi here, then keep 1 minus sign, put 0 here, then you'll get pi. This limits and all, you know to how to substitute. Okay, no need to teach again. From here to here, you could understand. That is not a problem. I am substituting the upper limit and creating a difference with the lower limit that everyone knows. Okay. This is the center of mass of the bipernate. So I can expect somewhere over here. So what is the distance from its center? No, not here. No, somewhere over here. Somewhere over here. Somewhere over here. So what is the distance? Distance of center of mass from the center is going to be 2r by pi. So 2r by pi. So going to be distance from the center. So now you know that the distance from the center is 2r by pi. And what if we ask that center is going to be 1 comma 0 now. So what is the center of mass coordinates? You know that from the center is going to be at a height of 2r by pi, right? So the center of mass is going to be 1 comma 2r by pi. Simple. Simple, no? Simple. That's it. That's why I told no. Don't get confused with that 0 comma 0 and all. Just shifting the coordinates, you just shift the center of mass. That's it. Okay. So this is all about today's video. Just one small revision we will do. This is semicircular ring. From here I am going to some angle theta. There I am taking a small mass of magnitude dm. Length is going to be very small. That's why I am written dl. From that circle's sector property, you can tell that arc length is equal to radius into theta. Where theta should be in radians, not in degrees. Very very important. Okay. Theta should be in radians only. So L is equal to r theta. From that relation, you can write dl is equal to be r times d theta. I am writing for this sector, so that you will get dl is equal to r times d theta. And second relation is that since the mass is uniformly distributed, you can tell that each and every point of the semicircular ring, each and every point of the semicircular ring, you are going to have same linear density. I mean, right, lambda. Same linear density each and every point, so that you can tell dm by dl is going to give lambda only. Suppose total mass is m, total length is l, then m by l, total mass by total length ratio also going to be lambda only. You take somewhere dm mass over here little bit greater and dl for that mass, still it's going to give lambda only. Lambda is uniform wherever you are taking for whatever portion you are taking. Okay, that's what lambda indicates, linear density. Fine. And again I have written that dm is equal to lambda dl from that relation only. Now this is very important, this you need to know. Integral of y center of mass is going to give integral of y dm by integral of dm. Okay. So this is a very important relation that you need to know. For x center of mass is going to be integral of x dm divided by integral of dm. Here x and y represents what? Represents the coordinates of the point we have taken, of the dm mass. Coordinates of the dm mass. Coordinate into dm mass of the coordinate divided by dm mass. For both integrals you need to apply. Okay. So from this we have written y center of mass is equal to, what is this? What did we do? From dl, from here we have replaced dl by r d theta. Why have we replaced? Because dl, you cannot simply integrate dl. As the length you are going to get from 0 to l. Then what is the use of this d theta? No, we need to convert dl into d theta and then integrate d theta only, not dl. Okay? Because dl is a function of theta. If dl is not a function of theta, then you can leave it. No problem. Since dl is a function of theta, from this relation we can see as clear as it is. dl is equal to r into d theta. So if L is varying, definitely theta is going to vary. If theta is varying, definitely L is going to vary. So definitely it's required for us to write it as dl is equal to r into d theta. Okay, after writing that, it's a very simple process. You're just going to integrate it, remove the constants, bring it outside, then get cancelled. It will get cancelled on its own. I mean, if you cancel it with your pen, or else it won't get cancelled. Okay. And then substitute upper limit and create a difference with the lower limit, and then you're going to get the answer is y com is equal to 2 or by pi. This is center of mass of this ring. Just don't memorize this as 2 or by pi. Circular, semicircular ring 2 or by pi, semicircular ring 2 or by pi. No. You need to know the derivation. You need to practice it 2 to 3 times. You need to keep it in your memory. The reason why I'm asking you to memorize this, not memorize these formulas is that suppose they're asking one question, let me tell that. No, there is one question came in our examination. Suppose there is one solid like this, okay, and the path of this solid, this curve, no, that equation they have given y is equal to 4x square. Now tell, and this is 0, this is L comma 0. Now tell how will you find? There can you use formula? Is there any formula for this? Already you know. Can you memorize this kind of formulas and all? This you can memorize, but do you think same shape is going to repeat in your exam? There is countless number of shapes. I can give this y is equal to 5x square. Your answer is going to be wrong. If I give y is equal to 4x cube, your answer is going to be wrong. So don't memorize the formula. Here what you need to do is you need to go for a dl distance and take one circular disc. Okay, if this is hollow, then you need to take a circular ring. Okay, if it's a disc, if it's a solid, uh, yeah, if it's hollow, then you will take a ring. If it's a solid, then it's a solid shape, then you need to take a circular disc. What is the difference between the ring and a disc? The ring is going to give dm by da. dm by da for ring. You will take density. What is the density? Sigma. Correct. For volume, you will take dm by dv. That's the difference. We're going to take here what? Rho. Rho simple, I don't know. Sorry. Okay. So it's the use. You need to know the formulas also. You need to mug up. I'm not telling that don't memorize the formulas. At the same time, you need to know the derivations also. So through this, you'll get the answer. The next video we'll see one more shape. For example, we'll go with hollow and solid hemispheres. So it's going to be a little interesting and difficult also. Not as easy as you tell. You need to, you can't take discs over there. You need to take small hollow hemisphere and then expand it from the 0 to the r distance. There you can't take theta as a variable. So that's why we'll discuss. Okay. So for this shape, this is how you need to derive it. So thank you for watching. Don't memorize again. Don't simply memorize. You need to memorize, but don't just memorize alone. You need to know the derivations also. Derivations also. Mic where